5-2 goes now that you know how to find z-score in the area. Going back to the very first thing we did with raw score data, how do you then take raw score data and convert it into a z-score so you can find probability? Okay, so we know if I had raw scores, so let's do this example. The average annual salary for U.S. teachers is $47,750. Assume the distribution is normal and a standard deviation is 5,680. Okay, so if I sketch in that normal curve and put in my mean and count by standard deviations, okay, we know how to find a probability percent if it landed on nice standard deviations and my question asked that. But this case, it's not. 35,000 is going to be somewhere here, 35,000, and 45,000 is going to be somewhere right here. So my question is asking me to find this probability, that area, right? The area and the probability is the same thing. So area in between, we learned how to do that. But in order to find this area in between, I need to know the z-scores for 35,000 and 45,000. Okay, so we have a handy-dandy formula. It's this. To find a z-score, I take the raw score, the x, which in this case will be 35,000 and 45,000. I take the x, I subtract the mean, and in this case the mean we had is 47,750, and divide by the standard deviation, which was given to us here. Okay, this converts any raw score into a z-score. So then I can use the table in my book to find that probability. Okay, so let's continue on with this problem. If I want area in between, I know that I need to know the z-score. I need to know the z-score for this value, the z-score for this value, so I can look them both up and subtract, right? Area in between. So let's find the z-score for 45,000. So to find the z-score, I'm going to take the 45,000, that's considered my raw score, take the raw score, minus the mean, 47,750, divided by standard deviation. Okay, now the big thing here is make sure you remember parentheses around the numerator or you'll get the wrong answer. So parentheses, 45,000 minus 47,750, close my parentheses, divided by 5680. And I get negative 0.48. We're going to round to the hundredths because that's the table in our book does the hundredths. So I know this z-score is negative 0.48. Okay, now I need the z-score for the 35,000. So same formula, 35,000 minus the mean divided by the standard deviation. So again, parentheses, but now it's 35,000, and I get negative 2.24. Okay, so going back to the lesson 5-1, I have two z-scores and I need area in between. So I look up the larger z-score, negative 0.48. So in my book, negative 0.48, 0.3156. Look up the smaller z-score, negative 2.24. Negative 2.24, 0.0125. And how do I find area between? I take the larger minus the smaller, and that'll be my area in between. So 0.3151 minus 0.0125, and I get 0.3026. That's my answer. right? So what's the probability that a teacher makes between $35,000 and $45,000 a year? 30.26%, 0.3026. Okay? Now, more than 40,000. So more than means what? More than means area to the right. So if I want more than 40,000, I need to find the z-score for that. So 40,000 minus the mean divided by standard deviation, right? You always need to get the z-score first. So that is 40,000 minus divided by negative 1.36, and remember, don't forget parentheses around that numerator. Negative 1.36. Okay, so now I have to think to my rules yesterday. More than means area to the right. So to find area to the right, I look up the opposite z-score, positive 1.36. So positive 1.36, 0.99131. So that's my answer, 0.9131. Okay, so the probability that a teacher makes more than 40,000 a year is about 91%. And when you get these answers, you should think, does that make sense? Well, if the average is 47, I should hope that most teachers are making more than 40, right? Because that 40 is less than average. Okay. Okay, so if you were applying for a teaching position and were offered $31,000 a year, how would you feel about that salary? Okay, so this kind of ties into like the teaching salaries, and everyone knows that South Dakota teaching salary is really low, North Dakota is really low, and you can figure that out with normal curve, knowing what's average. All right, and 31,000. If I converted 31,000 to a z-score, so let's change this to 31,000, okay, and that z-score, $31,000 minus 47,750 divided by 680 is negative 2.95, right? We know that anything more than 2 standard deviations from the mean is unusual. To get a salary of $31,000 is considered unusual. And actually an outlier is anything more than 3 standard deviations from the mean. So this is almost 3 standard deviations from the mean going to the left. So it maybe sometimes you gotta start somewhere. You gotta start with the low salary, but that kind of gives you an idea of, are you getting what you should be getting paid? Okay, let's try another example. The mean number of miles driven per vehicle annually in the United States is 12,494. That's my average. I need that for my formula, right? The average. Choose a randomly selected vehicle and assume the annual mileage is normally distributed with a standard deviation of 1,290 miles. What is the probability that a vehicle was driven more than 15,000 miles? Okay, so we first need a z-score. So more than, if I want x is more than 15,000 miles. Okay, so I'm going to take that raw score, 15,000 miles, subtract the mean, and divide by the standard deviation. And I get what? 15,000 minus 12,494 divided by, I get 1.94. Okay, now, am I doing area to the left, area to the right, or in between? And hopefully you said area to the right. More than means area to the right. So I'm going to look up negative 1.94, because area to the right, you look up the opposite, and negative 1.94 is 0.0262. Okay, so a little over 2% of people drive more than 15,000 miles a year. Okay, let's try the next one. Less than 8,000 miles. So I want someone drove less than 8,000 miles. Okay, so let's convert that into z-score. So here's my raw score minus the mean divided by standard deviation. So 8,000 minus divided by equals negative 3.48. And since it's less than, does that mean area to the left, area to the right, in between? And hope you know less than means area to the left. So to find the answer, I can just look this up, negative 3.48. So 0.0003, right? Pretty unusual for someone to drive less than 8,000 miles a year. Those are the cars you want to buy, right? They weren't driven very often. Would you buy a vehicle if you have been told that has been driven less than 6,000 miles in the past year? Okay, less than 6,000 miles is very unusual. And one thing to know is that because it'd be more than standard deviation of -3. Okay, I would probably ask some questions on those 6,000 miles because we know it's not good for a car to sit. A car needs to be driven. But maybe you got lucky and got a model car that's used, low mileage. I mean, what a great deal, right? Okay, so the probability of finding a car like that okay. Now, what happens when you find a z-score that's not on your table? If the z-score is so small, it's not on your table, we say approximately 0%. If the z-score is so large, it's not on the table, you would say approximately 100%. Okay, so this -5 is not in my table. So there's almost a 0% chance that you get a vehicle that's driven less than 6,000 miles in a year. All right, let's try another example. Monthly mortgage payments. The average monthly mortgage payment, including principal and interest, is $982, right? Just the mortgage. There's no insurance added to that. There's no anything else. Just basically what you're paying the bank. If the standard deviation is approximately $180 and the mortgage payments are approximately normally distributed, find the probability that a randomly selected monthly payment is more than $1,000. So more than $1,000 means area to the right, okay? So we first need to find the z-score. So $1,000, that's my raw score, minus the mean, divided by standard deviation. So 1,000 minus 982 divided by 182, 0.1, it's gonna round to 0.1. And since I'm doing area to the right more than, am I looking up 0.1? Nope. I'm looking up -0.1 because area to the right, you can look up the opposite. So -0.1. 0.4602. Okay. How about more than 1,475? So that's another area to the right. So 1475, that's my raw score, minus the mean, divided by standard deviation. And I get 2.71, but it's more than area to the right, so am I looking up 2.71? Nope. I'm going to look up a negative 2.71 and a negative 2.71 is 0.0034. Right? So it'd be very unusual to have this sort of mortgage payment. You're talking about a pretty big house there, right? Or in a pretty good area, right? Depending on where the house is. Okay? So it jumped, for just do 1,000, it was 46% of people. But to do 1,475, it was 3.4% of people. Okay? So not quite an outlier, 3.4%. Between, here's a good one to practice, between 800 and 1150. Okay, so area in between, we need to recall, how do we do area in between? Okay, we look up both z-scores and subtract the probabilities. So in order to look up both z-scores, I need to find the z-score for both. So I'm just going to go ahead and do the bigger number first, because that's going to be the bigger z-score. So 1150 minus the mean divided by standard deviation is 0.92. Then I'm going to do the z-score for the smaller 800. So I'm going to do 800 minus the mean divided by the standard deviation. And I get -1, okay? So now, look up the z-score, 0.92. So 0.8212. Look up the smaller z-score, -1. 0.1587. And then what do? I subtract them, right? I look up the bigger z-score probability, I look up the smaller z-score probability, and I subtract them. That's how you do area in between. So I'd get 0.6625. A little over half, right? Over half the people pay between 800 and 1150 a month. All right, maybe let's do one more here. Credit card debt, right? This is huge, especially right now. The average credit card debt for college seniors is $3,262. If the debt is normally distributed with a standard deviation of 1100, find the probability. The senior owes at least $1,000, okay? These are tricky words. This is where the verbiage always gets a lot of people. What does at least $1,000 mean? Well, at least $1,000 at least, you owe at least $1,000. That means $1,000 or more. Okay, so this one's area to the right. You owe at least $1,000 or more. Okay, so I would need to first off find the z-score. So my raw 1,000 minus the mean divided by standard deviation. So 1,000, and this should be a pretty high probability, right? Because it's less than average. Divided by, so negative 2.06. And I'm doing area to the right, so I'm going to look up positive 2.06, right? You always look up the opposite when you're doing area to the right. So a positive 2.06 0.9803. Okay. 98% of seniors owe at least $1,000, and that makes sense because average is $3,200. Okay, how about the senior owes more than $4,000? Okay, so more than $4,000, what does that mean? That means area to the right, more than 4,000. So we first need to find our z-score. So 0.67, am I going to look up 0.67? No, that would be if it was less than 4,000. It doesn't say less than 4,000, area to the left. It says more than 4,000, area to the right. So I'm actually going to look up negative 0.67. So negative 0.67, 0.2514. So 25% of seniors owe more than $4,000. A senior owes between $3,000 and $4,000. Okay. Well, we know the z-score. The z-score for 4,000 we got right here, 0.67, not negative 0.67. That was me changing it to find area to the right. You have to go back to the original z-score, 0.67. Right? Because remember, area in between, you don't change anything. You just take the exact z-scores. So I know I don't have to do that work. I already know the z-score for 4,000 is 0.67. So the only other work I need to do is find the z-score for 3,000. So 3,000 minus the mean, divided by standard deviation. Is negative 0.24. Okay, so I know this z-score is negative 0.24. After I have both z-scores, remember what to do? Area in between? I look up the larger z-score, 0.67. So 0.67 is 0.7486. I look up the smaller z-score, negative 0.24, negative 0.24, .4052, and then I subtract them. So 0.7486 minus 0.4052, and I get, whoops, 34, a little over 34%. Okay, so converting raw score, the number they give you, to a z-score, and then remember your rules for looking up. If you're looking up less than, no more than, that would be area to the left. Area to the right would be more than, at least, right? That's all area to the right. Or you have in between. When you're doing area to the right, you look up the opposite z-score. When you're doing area in between, you find the exact z-scores, look them up, and subtract the probabilities. Okay, so your homework for this section, for 5-2, is on page 249. And it's 7 through 12. Okay. Remember the odds are in the back, so you can check those. And then remember anything unusual right? Because you have parts A, B, C, and D for each one. Remember, anything unusual is less than 5%. So after you do A, B, and C, and if you see any of those is less than 5%, you would state that's unusual.